So today we're going to talk about AWS Lambda and running Golang on it. So I'm going to warn you, as on these slides you're going to see a result of my poor Photoshop skills. After this introduction, I know that probably I should ask our host to help me with this. They are really into Photoshop. So thank you. But you should tell me that earlier. So let's begin. So please let me know who familiar with Golang. Okay, a lot of people. That's good. But I will tell it anyway. So Golang is a programming language developed by Google and released in 2009. Yep. And very popular tools like Kubernetes, Docker, Prometheus, you all heard about them here today and yesterday, was built in it. So, and who knows about AWS Lambda? Okay, one more thing. Usually I'm trying to build my presentation special. I'm doing this like building it around some fictional character. And if you take a closer look to the AWS Lambda logo, you can probably guess who that will be. But let's go further. Oops, it's clicking wrong slide. Or it's clicking, click, yep. Agenda. So today we will talk about AWS Lambda on maybe half-life. It's really hard to tell just from the logo. So let me know, who knows about the half-life? I can see some people who didn't raise their hand. What you were doing at school? Smoking on the backyard? Or maybe studying algebra? So let's go ahead. Then we will talk how it differs from servers, how serverless differs from running code on servers. Then we will talk about squirrels, what they have to do with it, and how does it work internally, and to go or not to go into serverless. So AWS Lambda is serverless computing platform. Does it really mean that there is no servers? I was really scared that pictures will be very pixelated, but they look nice, so go ahead. You probably already seen this quote if you visited Keynote on this stage yesterday morning. It was presented by the CTO of Cloudflare, totally the same quote. And I tend to think if the CTO of Cloudflare is using the same quote as I, probably I'm moving in the right direction. So there is servers, but they're not yours, so you don't need to worry about them. If you're familiar with the topic enough, just from the beginning, you could be able to guess what's wrong with this slide. Like, the main problem is with the picture. It's not from Half-Life at all. It's taken from Portal. But it's important, because these AI robot thinks just like servers. That's heartless machines that just want to make you cry all the time. Probably it's familiar with Jenkins. So, how does it differ? So, the main benefit is you pay for what you use. You're paying for invocation count, paying for invocation time, and paying for resources that you allocated. It's like pretty complex to calculate, but it's mostly cheaper than your servers, depending how you use. It has cold starts. We heard a lot of talks about serverless during the DevFest today and yesterday. And a lot of people mentioned that cold starts are bad because they are slowing down your program. So the cold start is a time taken by your serverless computing platform to bootstrap environment for you to run your code. And there is warm periods. This is a time when you can reuse already bootstrapped environment to avoid the cold starts. We will take it closer look later. So all the Lambda invocations has a timeout. For AWS Lambda, it's 5 minutes. If I'm not wrong, for Google Cloud Functions, it's 9 minutes, and Azure, it's 5 minutes as well. So if your code isn't done in 5 minutes, it will be simply killed. And it's your fault that you let this happen. Lambda invocations are stateless, basically, almost. Basically, each invocation is independent, and you can't share state or any context between them. Only exception if your execution happen on the same host which is already warm. We will take a look at that later as well. So event-driven code execution. This is really important because you can trigger your Lambda in numbers different ways, especially like Amazon has integration from most of all of the services with Lambda. So basically, during the upload to S3, you can trigger Lambda to do something with your picture. You can trigger it via HTTP call. You can trigger it based on a schedule or just simply from the AWS SDK. And AWS Lambda has very generous free tier. And unlike other services, it resets every month, so it's not limited to 1 year usage since you register. So you can use it all the time, and it mostly will be for free for you. It depends how you use it. If you build the whole backend on it and you have millions of requests, you will pay for sure, but if you want to play with it or you're doing some helper stuff, it will be completely free. And the endless horizontal scaling. Basically, AWS will scale your executions to a number of containers the same as the number of parallel requests that it has to handle. So basically, if somebody concurrently executed it 200 times, then you have 200 containers executing that code. That's not always good, because like if Lambda can scale endlessly, does your backend can? For example, if Lambda goes to MySQL database, can it handle 1,000 concurrent connections, queries? It depends, but Amazon, probably on the last reInvent, introduced the feature like throttling. So you can explicitly set like do not scale between more than 300 containers at the same time. And endless, it's not really endless. By default, you have a soft limit in your account for 1,000. You can increase it, but I don't remember what is the hard limit. Like 1,000 parallel execution was more than enough for anything. And no operations, like no boring stuff. You don't need to go to servers, you don't need to use SSH to play with them, you don't need to reboot them, you don't need to patch them, you don't need to do anything. You just push your code and that's it. This is the squirrel I was talking about. This is SAM. Basically, this is serverless application model. This is official extension for CloudFormation from AWS, which makes it easier for you to describe, deploy, manage your functions. It comes with a SAM CLI tool, which lets you do the same from your terminal. This is really nice, because if you wanted to deploy your function with the CloudFormation, you need to define really a lot of resources, and it will be a huge YAML for a couple hundreds lines. But SAM abstracts it away from you, and so you just define Lambda functions and it trigger, and it will generate real CloudFormation behind the scene. And there is a serverless framework. This is basically doing the same, but this is open source, and it's on the market for much longer time. It has like 20K stars on the GitHub. And it also generates CloudFormation for you, but it can work with different cloud providers, so like not only AWS. You can, with help of plugins, you can write your own plugin, but you can, by default, you can use Google Cloud, Azure, OpenWhisk, even Kubeless now, and something more. But for Golang, SAM seems better because like someone could even say that serverless inspired SAM because they're pretty similar by design. So for the Golang, SAM is better because serverless doesn't allow you to execute locally your Golang function. It can be used only for Python and Node.js, if I'm not wrong, but I don't remember. But with SAM, you can run your Go code locally as well, and also SAM can emulate HTTP triggers. Basically, it starts the server, which you can call your HTTP request, and it will execute your code. Like serverless can't do that. Also, SAM has built-in examples for all kinds of events that AWS can generate for you, like the same S3 upload and others. So it's really nice for local development and managing. But actually, personally, I'm using the serverless framework because I'm using it for a long time, and I have all the processes built around it. But maybe someday I will try to use SAM. It looks better now. But how does it work then? Like if there are no servers and your code has all the limitations, we already know that it's pretty different from servers. So how does it work internally? Let's take a look at, this is the only code snippet that we'll see here. This is my minimal code for Lambda function on Go. And it has just a couple very important lines. The first one is the import. This is an open source AWS library for Lambda. You have to import it to use to Lambda be able to execute your code. So this should be the most important line of your code. Then you can put any number of code into the init function. The init function will be executed before your handler, and it will be executed only once during the code start. We will have the whole slide dedicated for code start, so we will take a closer look, but remember that. Also, we have actual handler. Handler, this is the place where your business logic goes. A handler could have a number of different function signatures. You can see them on the right. It could return something, it could accept something, but also it could not do that. So what you want, choose from these signatures. And then you should have a main function, which will consist of Lambda start and your handler. This is the place where AWS Lambda is the library taking care of your handler. We will come back to that. Yeah, this is a slide I told you about. It's about function lifecycle. This is the best way to explain how cold start works and what is warm start, what is cold start, and etc. Basically, this slide taken from highly recommended AWS webinar called the Become Serverless Black Belt. There is YouTube and slide share link. So if you're using serverless and you want to know more about this, I highly recommend to watch it. It's like 40 minutes, and it has all the important stuff in there. So what's the function lifecycle? There is basically 4 steps. The first one is that AWS has to download your code. So basically, when you deploy Lambda function, you make the code package, zip file, and deploying it to somewhere, probably S3. Yeah, S3. So Lambda has to download your code to some node where it's going to be run. Then it has to deploy container, your environment, where this code will be executed. Then it has to bootstrap runtime, do all the initialization, and then start your actual code. So AWS applies the shared responsibility model. Like it's similar for almost all of the service AWS. What does it mean? This means that there is some parts of service that AWS taking care of, and there is some part of your responsibility. You're responsible for making it work right, correctly, fast enough, etc. So you can see it divided by the line in the middle, what is AWS responsibility and what is your responsibility. So what AWS do? So download your code. This AWS optimizes like improving network to improve the download speed and unpacking your code. The only thing that you can do to make it faster is to make your code smaller, to deploy smaller packages. Then starting new container. This is also AWS optimization, and you have no control on it. So basically, it spawns some container. They doesn't say if it's Docker or not Docker. They just call it container. So and we don't know what is there, but you can't manage it. Or actually, if you're using Lambda, if you want to use Lambda inside of VPC, basically to be able to access resources in your private network, there is one more step. It's network interface allocation and attachment to your environment. So it will take a couple more milliseconds. So if you're running Lambda code inside of VPC, it will be slower than running in non-VPC. The rest is your responsibility. So bootstrap the runtime. This is actual time to execute your main code body. So basically, it doesn't matter which language is used. If it's Golang, then it's time to start the binary and do all the code that's not in handler. So all init and everything in main function under your Lambda start call. If it's Python, they have some, or Node.js, they have some their wrapper library which imports your code and executes it then, and I don't really know how it's working inside. And then starting your code, this is the one that actually located in handler. Why is this separated in 2 different steps? Because for Lambda, it's really 2 different steps. If you build just simple binary, it would be 1 step, because you called binary, it executed some code and exits. In case of Lambda, it doesn't. And why is that? We will see on the next slide. So basically, this diagram is inspired by the article here. Basically, it's not inspired, it's a bit stolen, but I did my modifications. So let's take a look here. This describes how AWS Lambda for Go works internally. So we can see here the trigger event. This could be any kind of trigger. So it could be different AWS service. Could be we calling Lambda via AWS SDK. It could be HTTP trigger, like any kind of event. Then goes Lambda service. This is the one actually receives the call to run Lambda and do the bootstrapping of the environment, like trigger the functional lifecycle. So it finds the free node, puts the container there, puts your code there, and starting executing. But what's happening inside? You can see here red is a compute substrate. Basically, it's some kind of compute power where it's running, probably some servers managed by AWS. Then you can see Lambda function, the purple one. Lambda function consists of your code package plus your language runtime. In case of Go, it will be language environment. So it will be Go binary, plus it could be some files that you put into the zip package with them. And then Go runtime is the actual what's happening inside of your binary. So basically, AWS starts your code via RPC call. So since AWS Go, you can see here, the yellow is a steady leap, AWS Lambda Go, and our code is just the green part. Since AWS Lambda Go is open source, you can open it on GitHub and take a look what's happening inside. So what's happening? It's actually starting the TCP server, which is handled by steadylib, like net and netRPC. And then AWS Lambda service does the RPC call to your binary, so for the open port, call called invoke request, and then payload transferred to the function and handler. This is interfaces inside of the this open source AWS Lambda Go. What it does some additional validations of your payload and marshalling. As a result, you're getting the interface or the struct that you defined as input in your handler ready in your code. Then you do your business logic, whatever it is, and return the response. This will be an interface. It could be any response that you want, and error. And it goes all the way back. So, like, it's very simple. It's nothing special in there, but the rest of the logic hidden inside of AWS Lambda servers, as we don't know about it, like how it choose the free node, what it do to deploy your environment, etc. We know just what's happening once environment is ready, that it's ready and listening for RPC call. Once RPC call arrived, it's invoking your handler and code in it. So, since we already know it differs a lot, do we need to write code difference? What to do to avoid pitfalls with, I know, ACID? Probably. Let's take a look. So we already find out that cold starts are the worst and inevitable part of serverless, and we need to fight with it. So let's stay warm and put protective suits. Or try to reduce the cold starts to make your code more responsive. So this is like mostly official AWS recommendation plus my recommendation. So better to avoid fat monolithic functions. What does it mean? That AWS recommends to have single purpose function which has single purpose. Like do not do any kind of routing inside of your function. For example, you could build, I even saw the open source repositories which turns your HTTP router into Lambda router, and it does tons of routing between different kinds of logic inside of one binary. This is especially bad when your different pieces of logics require different dependencies. So all dependencies stuck in one binary makes big binary. Instead, if you could have a couple small binaries. And also, having multiple functions increases visibility because you will have, for example, a function create user, function delete user, and if something fails, you will see straight away on the included monitoring which part of code is failed. But if you had like one function user and it crashed, you know that something happened with user and you need to go to the stack trace and looking like which part of your code is failed. But with many functions, you know straight away which business logic fails. Like read only what you need. I believe that like most of the functions need to be initialized. It needs some configuration files. There is different way to provide them, like via environment variables. If it's secrets, you can provide it via SSM parameter storage on the AWS, or you can put simple JSON file in your zip package and read it on the beginning. So the idea here is just to read what you need, because reading extra data make it slower and consume more memory. So if, like, for example, if your function still have a couple logic branches, and the logic branches need only configuration A, not configuration B, then better to read only configuration A, because maybe you won't need configuration B. Why to spend time on reading it? Pretty the same comes with do less initialization. The idea is not to put all the initialization inside of the init function, because it will increase the cold start. Like as well as if you have configuration A and configuration B, and logic A requires configuration A, and the same for a different one. So do initialization on the beginning of the logic. You can have some global variable called configuration, and you can check if it's null, then you need to do initialization. If it's not null, then you can use already configured function. And do the same for different config. Do not read everything on start, because it makes it slower. And think twice before adding new dependencies. Basically, this goes with the best practice for the Golang, like better to copy some method from open source libraries and put all the library in your code if you're not using it. The same goes here. Like you can add some dependencies and it will make your code bigger, and we don't need that, especially if you're using Node.js. Like you can add one dependency and PM will take 20 more. So better not to do that. Like try to use without additional dependencies. And allocating more resources. There are proofs that the more resources you are allocated, the faster code to start, like the shorter code start will be. So if it makes sense, if performance is very important for you, try play with the different resources settings to see how long it will take. Next one. As I told, Lambda could execute parallel execution on itself. Like you don't always need use concurrency of your language, like these parallel Gordon Freemans in parallel worlds. So basically, you need to remember that if your code couple times at the same time, it means that couple environments were spin up and the parallel execution of your code is running. But it doesn't mean that you don't need to use concurrency at all. Especially in Golang, you have perfect Go routines, and if your logic fits well with them, you can use it. Like no problem. Just keep in mind that your executions are parallel by default. And your environment is ephemeral, so you can't rely on it at all, but you can try to reuse it. How to do that? Like as I told about warm functions and cold functions. So when function executed first time, it's experience cold start, and then it stays warm for some time. And if next execution code after that, there is pretty big chance that your code will be executed on the already warm environment. And as I told that it's called by the RPC call, which goes straight into your handler. So basically, no code besides the handler will not be executed. So this also includes global variables. You can put some variables on the top of your file code and store some global configurations there. And then if your code happens to be executed on the same machine that already initialized, then you already have these values in there and you don't need to initialize it again. So keep in mind that you can store some important data in global variables that can be reused. The same goes with the file system. AWS Lambda allows you to use half of the gigabyte on the TMP, in the TMP folder, and you can use it whatever you like. You can store some temporary data. You can use like file system cache. And it's, again, if your code happened to run on the same already warm environment where there's data already was populated, you can reuse it. You don't need to do anything. You don't need to download it or generate it again. You can just take whatever is there. And also you can keep open connection. For example, it stands for database connection. You could open connection during the first execution, during the cold start, and then keep connection open while it's warm and reuse it later. Oh, and that's it. And probably one of most important things is to handle failures. In order to handle failures, you need to understand retry policies. And in order to understand retry policies, you need to know what kind of Lambda executions could be. So there is the simplest one, the synchronous one. It happens when you execute Lambda from the AWS SDK or explicitly invoke synchronously Lambda, then it will return your result, and this function will never be retried. Retries will be responsibility of the client. The same goes for HTTP trigger. If you call the HTTP endpoint, it will be synchronously waiting for the response, and if you got the error on your side, it's your responsibility to retry. There is also asynchronous calls. These calls made by most of the AWS services. Basically, it just calls it and that's it. And it will be retried 2 times. So you could wonder, for example, if you had some bug in your code and it got triggered, you can wonder why you have 3 errors in your log, because it tries 1 and then it retries 2 times. And there are also stream invocation. Stream invocation, as far as I remember, called only by Kinesis streams and CloudWatch logs. So basically, this one going to retry until data expires. For example, for Kinesis, it could be 24 hours. Like, you don't want to lose data, so you have time to fix your bugs. Like, it will be keep retrying and retrying. But, one more. And you can use data ladder queues to put your failed invocations in and then replay it by yourself. But keep in mind that retries are built as new execution. So if your function keep retrying Kinesis streams for a whole day, you're going to pay for it. So, yep, next. Smart resources allocation. This is also a slide taken from AWS webinar. It's a really good one, and it helps to understand that if you want the cheapest execution, it doesn't mean that the lowest resource is going to provide it. For example, this is the Lambda, which calculates prime numbers for the number of times, and its result on different configuration, 128 megabyte, 256, and more. So we can see that 128 megabytes, we're saying that AWS Lambda allows you to configure only a memory, but it scales CPU for you linearly with the memory. So the more memory you give, the more CPU you get. And it stands for, as far as I remember, 1.8 gigabyte. All the memory configuration up to 1.8 gigabyte, AWS gives you environment with 1 CPU, virtual CPU. And if you give more than 1.8 gigabyte, AWS will allocate you environment with 2 virtual CPUs. So if you want to use concurrent some execution inside of your code, you may need more CPUs. So prime numbers calculation with 128 megabytes of memory executed for 11 seconds, even almost 12, and cost us 2.5 cents. The 256 executed twice faster and costs a bit more, almost 3 cents. The same goes with 512, but when you allocate 1 gigabyte of memory, the function executes in 1.6 seconds, and it costs practically the same as with 128. So sometimes it makes sense to play a bit with configuration to find out which works best for you. And there is open source tools which does exactly that. You can provide your functions for this tool, and it will launch for you with different configurations, run a couple of times, and define which one is the fastest and the cheapest for you. So this is very important. Like, the cheapest one, not always the cheapest one, paradoxically. Go next. Then, to go or not to go? Like, which case should we use Golang for the AWS Lambdas, and which case Node.js or Python will do? So, Node.js Python works best for small functions with no or very little dependencies. Why is that? Because this interpreted languages, and it has language runtime installed in the environment, and your code package will be just simple txt file for a couple kilobytes, and it will be executed on that environment. So the code start for downloading your code will be really fast because it's downloading just a couple kilobytes. The same goes for functions that depends on AWS SDK only. the same reason, because AWS provides environment with pre-installed AWS SDK. So, for example, if you have a function that do, I don't know, when you upload to S3 and it takes this image and upload to different S3. So in order to do this operation, you need AWS SDK only, and this will be a couple lines of code on Python or Node.js, and it will weigh the same, like a couple kilobytes. It will be a tiny file. But if you do this with Go, you need to import the whole AWS SDK, which is huge, and it will be like 10 gigabytes or 10 megabytes binary. So, and when you zip it, it will be like 7 or 6 megabytes. So there is a difference. When should you use Go? Like, if you like writing code on Go, then everything what didn't fit in these two categories, just do it in Go. And this make Gopher happy. Not Elon Musk as on the keynote, but Gophers are happy. Gophers as important as well. And when to use Java? There is like very good use case. Never. Because it doesn't make sense. Like I could think of some use cases. For example, if you want to use inside of your Lambda function some pre-built jar or var, you can deploy it into Java environment and trigger it. But this is very rare use case. And like if you're writing some of your custom codes, I don't see when you can write it in Java. Like it doesn't make any sense. This is like really good articles. The first one is about cold starts. This is a guy who did some research about cold starts on different cloud providers with different language runtimes, with different versions, with different configurations. There are tons of graphs, and you can see and figure out for yourself and try to understand how cold starts and warm starts works. Second one is the same one where I stole the Lambda graph, how it works itself, AWS Lambda Go. And these two are really good ones. It's like digging into internals of Lambda by, I don't remember how guy's named. He's a security researcher, and there is like pretty good hidden points which you can read and know about. If you want to open these links right now, you can scan this QR code, and it will lead you to the presentation at all, but it's a bit cut. I don't know, maybe it will scan. And basically, want to say thanks to the Arcade Rage and Mark Vikus. This is the guy you may know from comics How to Rescue Princess in different programming language. And this is the same guy who made all the incredible picture of legendary Gordon Freeman that I used in this presentation. So you can find them by hashtag 30 days of Half-Life. And basically, that's it. But we have a couple more minutes, and we can spend them for questions, or I have a tiny demo. So let's vote. What do you want? Okay, this make Volodya Stoiko unhappy. Okay, I need to share my screen. Could you please change from mirror display? I don't know, what should I do? Yeah. So I have a small function. Can you see something? So what to do? So we have a tiny function which will be triggered by HTTP handler. And there is a Go routine which runs in the background. And it tries to write a file into the TMP folder for every second. Actually, it's here in separate package. So basically, there is ticker every second. And writing file with context TikTok function started some time ago. So, and our handler, which will try to read all the files from TMP folder. So basically, Go routine who is writing them, and our handler, which by our request, reads all of them. So I believe it's already deployed, but I can do it again. I'm deploying this with serverless. I can show you serverless config. It uses not my AWS account. So a very important thing for Golang is to set package individually because by default serverless packs everything in the current directory. It's fine for Node.js or Python because you need everything there, but for Golang you need only binary. You don't need all the stuff besides. So here in the function, we define function, pass to the binary, events that going to trigger it, as is some my internal configuration, and package, we say exclude everything besides tick binary. This way we will make our package smaller. So it's already deployed, and we can see service endpoint. So also, let's trigger it. So yeah, we executed first time, and it tried to read the files in the TMP directory, but there was none. But now GoRoutine started, and it's spawning files every second. And in the files, you can see content, function started 3 seconds ago. Like, it's going to increase, because I am storing the execution time into the global variable, and since environment is still warm, it's still there. So basically, we are reusing the same environment. If it was the new one, we should see all the time when function started 1 second ago. But if I trigger it, I will see it 38 seconds ago. So basically, this environment already warm for 1 minute almost. But there is a question: if GoRoutine writing every file every second, why you can see only 2 files if 40 seconds passed? So that's the mystery here. Anyone has ideas? No, it's a new file created, just incrementing. No. So basically, AWS has custom resources scheduler, and while your function is not executed, it's your code, your process doesn't get any of processor time. So basically, it's frozen in time. It just doing nothing, and you can't do anything without it. This is the mystery of AWS Lambda. Like when it before it do RPC call, it unfreeze it. So yep, that's why you can reuse connections. You can open connection, and everything will be frozen in your binary at the same state when your handler exits. So, and if you trigger it once more, you can see it's already 2 minutes. So it's already warm for 2 minutes. And official AWS documentation says that the function stays warm for like 5 minutes, but there's plenty of research who proves them wrong. And there is like 20 minutes, even 1 hour. It's a bit randomish. And one of the guys tagged in Twitter somebody from AWS Lambda team, and they told like Lambda team keep playing with Lambda all the time, so these values can change. So you could never know. So the environment like pretty random. You can never rely on some patterns. You can always treat your code as it will be executed independently, stateless, but you can try to reuse other things. So that's it from me. Oh, I forgot important things. There is also a pretty cool picture. And that's it. Thank you.